So I just reread my instructions and it looks like I gave some points to people that I wasn't going to give points to. It says show all work. Here's the part that I gave points to. Those of you who answer with decimals that aren't allowed. It says use exact values unless otherwise instructed. Provide correct units and sentences when needed. Rationalize the denominator for bonus points. Most of you did fantabulous with that. So the first part is converting the following angle to radians, and we're going to take 262 degrees, no decimals, reduce if necessary. So it's a degree, and this degree symbol matters. It is a unit. And we're going to divide by 180 degrees to get rid of that degree symbol, but we need a pi as well. So now we just need to take that 262 and 180 and reduce them. The degree piece is gone. Now I just need to reduce. And I know it reduces by 2. We'll get there. So that should be 131. 131 pi. 2 would be 90. And that is as far as it reduces that I know of. If anyone knows anything different, please let me know. The next one is convert the following angle to degrees. Now, this one people struggle with a lot. Do not put a pi sign with this when there's not one given. I put radians here just to let you know that it wasn't degrees, to let you know it was in radians. So this is just 3.5, not 3.5 pi, just 3.5. And to convert from radians to degrees, you multiply by 180 degrees over pi. Now you just put this in your calculator, 3.5 times 180 divided by pi. 3.5 times 180 equals divided by pi equals. And I got 200, what are we rounding to? The 10th place. So it's one decimal place, so 200.5. And this is your degrees. Do not forget your degree symbol. All right, next one is find one positive and one negative coterminal angle. Pardon me. So 262 degrees. To make another positive, be adding 360 degrees. So 622 degrees would be my positive. And then I need to take my 262 degrees and subtract 360. And that gives me negative 98. There's a positive and a negative. A circle has a radius of r equals 12 centimeters. A central angle of 40 degrees and intercepts an arc. Find the arc length, round to 2 decimal places. So I told you S equals R theta, where theta must be in radians. Muy importante, otherwise it's going to be wrong. So S equals, our radius is 12. Our theta is 40 degrees. So 40, changing that to radians. Actually, I could just leave it like this, couldn't I? I don't even need to reduce this. My eraser's crap. So I'm just going to put it in exactly like this. 40 pi over 180. I'm not even going to reduce, because what if I reduce wrong? All right, so 12 times 40 pi equals, divided by 180 equals, and I got 8.3775, and I'm rounding to 2 decimal places, so 8.38. And this is a unit of centimeters. Most of you did fantastic with that. All right, in a right triangle, an acute angle of 55 degrees, an adjacent side of 6 meters, find the opposite side, okay, and it's going to be in meters. We have to make sure and answer with meters, and we're going to round to the 10th place, which is 1 decimal place. Now, I need the opposite side, I have the adjacent side, so which trig functions can I use? Out of sine, cosine, and tangent, I can only use tangent, because sine uses hypotenuse, cosine uses hypotenuse, only the tangent of theta is opposite over adjacent. All right, so the tangent of 55 degrees, you can never write just tangent is equal over A. It's tangent of an angle. Tan doesn't mean a dang thing if you don't have an angle with it. So is equal to the opposite, which we don't know what it is, over the adjacent 6. And I'm just going to multiply. 6 tangent of 55 is equal to the opposite. I need to make sure my calculator is in degrees because otherwise it's going to be wrong. All right, because it is a degree, not a radians. And I'm just going to go 6 tangent 55 equals. And I got 8.56. How many decimal places? Just one. So 8.6. So the opposite side is 8.6, same unit, meters. All right. If you have any questions about this, please make sure I answer them before the final. All right, a cat is stuck in a tree. All right. Meow. All right, kitty. All right, stuck in a tree. A ladder makes a 65-degree angle with the ground, okay, and touches the branch 20 feet up. So from here, from the kitty down, is 20 feet. We need to know how long is the ladder the owner is using, round to the nearest foot. Show your work and write sentences. All right, so we've got opposite and we need the hypotenuse. That's sine. So sine of theta is opposite over hypotenuse. So sine of 65 degrees is 20 over the hypotenuse. I'm going to cross multiply here. So sine 65 is 20. Divide both sides by sine. I'll get there, 65 degrees. All right, so H is 20. Make sure I'm in degrees again. Yep, so 20 divided by sine of 65 is 22.06. Actually, 22.07. But we want to round to the nearest foot. Now, here's the deal. Everyone answered that did get this right, answered the same way. You all said 22. If we are talking about a real world problem and 22 might not be enough. So you should, even though it's not a 0.5 or greater, you really should have rounded up to 23. I accepted 22. I would have accepted 23. None of you thought to do that because you are still stuck in the concept of rounding means it has to be 5 or greater for the rounding digit. That's not always the case. If you have a little bit more, if you need more than 22, you should go to 23, but we're past that. All right, so the ladder needs to be, and I would have accepted 22 or 23, but there needs to be units, feet long. Either one of those would have been acceptable, okay? Next one is evaluate exactly with no decimals. Where's my unit circle? So 240 degrees, my unit circle is right there. And sine of 240 is my y value. So negative square root of 3 over 2. Cosine of negative 210. So where is 210? 210 is here. So a 210 would be here, but it's negative. So we have to go the opposite direction, the same amount. So it's right there. It's our 150 degrees. What is our cosine at that point? It too is negative square root of 3 over 2. No, it was not a trick. All right, find the reference angle for 240 degrees. The 240 degrees is in quadrant 3. And quadrant 3, you have to use the absolute value of theta minus 180. So absolute value of 240 minus 180. I need to seize. All right. Stick off wicked. So 240 minus 180 is 60. Absolute value of 60 degrees. It's already positive, so we're going to leave it as it is positive 60 degrees. All right, and the next one is 17 pi over 6. This is going to be bigger than 2 pi. How do I know that? 17 divided by 6 is bigger than 2. That's how I know. First thing I'm going to tell you to do is convert this to degrees because it will make your lives easier. 17 times 180 over 6. Is 510 degrees. Is that right? I don't trust myself right now. 510. So this would be 17 times 180 over 6 is going to be 510 degrees. All right. We're going to change this to find our reference angle has to be between 0 and 90. It has to be quadrant 1. So I'm going to start by subtracting 360. And that's 150. All right, now that 150 lives in quadrant 2. It has the same formula for finding the reference angle as quadrant 3 does. So quadrant 2 is absolute value of theta minus 180. In this case, it's 150, which is the absolute value of negative 30, which is 30. Now, the question is asked in radians. Your answer must be in radians. So what is 30 degrees in radians? Pi over 6. So your answer was pi over 6. Nine. If sine of theta is negative 7/9 and theta is in quadrant 3, find the other 5 trig functions. All right, so if sine squared theta plus cosine squared theta is equal to 1, that's our Pythagorean theorem, you can use negative 7/9 for sine, and we're going to solve for cosine. When you square this, it's no longer negative. A negative squared is a negative times a negative, so that's a positive. So this is 49 over 81 plus cosine squared theta is equal to 1. Now I need to subtract 49 over 81 from both sides. Do not freak out over this. This is not hard. Just change this 1 to the denominator over itself. It becomes cosine squared theta is equal to 81 minus 49 is 32 over 81. Take the square root of both sides. So the cosine of theta is the square root of 32 over 81. Hold on. 32 has a 16 in it. So it also has a 4, but 16 is bigger. 16 is a perfect square. So this breaks down to the square root of 16, the square root of 2. Why is this 81? It should be a 9. Time for me to go back to sleep. So sorry, y'all. There we go. So the square root of 16 is 4. Left with the square root of 2 over 9. This is the cosine of theta. This is, oh, it's in quadrant 3, though. We'll come back to this. We'll come back to this. For right now, I'm going to circle it, but I'm going to have to check my signs because we are in Q3. I'll do all of it, and then I'll come back and check my signs. Oh. Everything is just itching today. All right, let's go to tangent. Tangent of theta is sine of theta over cosine theta. Sine of theta is negative 7/9 divided by cosine of theta is 4 square root of 2 over 9. We're going to keep, switch, reciprocal. Gone. And this is left with negative 7 over 4 square root of 2. I told you I would accept this as an answer. Oh, we need to be careful with this sign. I need to go ahead and do my sign for cosine. Cosine's negative in quadrant 3. The only two things that are positive in quadrant 3 are tangent and cotangent. So this should be, let's just fix this now. So it should be positive. So tangent of theta is 7 over 4 square root of 2. Now, if you rationalize this, which is totally cool, you get your extra bonus point. You're just multiplying both the top and the bottom by square root of 2 over square root of 2, and you're left with 7 square root of 2 over square root of 2 times square root of 2 is square root of 4, which is 2. 2 times 4 is 8. That would be your bonus point. All right, let's go up here to cosecant. Is 1 divided by sine. So 1 divided by negative 7/9 is 1 times -9/7, which is -9/7. Secant is 1 divided by cosine is 1 divided by -4 square root of 2 over 9 is equal to -9 over 4 square root of 2. If you rationalize your denominator, your bonus point. And then last is your cotangent, which is your cosine over your sine. Cosine was, we'll get there, -4 square root of 2 over 9 divided by sine is -7/9. Keep, switch, reciprocal. Negative times a negative is a positive. Nines are gone. So this is 4 square root of 2 over 7. All right. Last one on this page. Evaluate exactly, no decimal. Tangent of 5 pi over 3. Let's go look at 5 pi over 3. 5 pi over 3. Cosine is 1/2. So tangent of theta is sine of theta over cosine theta. But we don't write that because we know what the angle is. So the tangent of 5 pi over 3 is sine of 5 pi over 3 over cosine of 5 pi over 3. It would be like if I asked you a question and you just said a word blue. Okay, what does that mean? You have to define what it means. All right, so sine of 5 pi over 3 is negative square root of 3 over 2 divided by the cosine is 1/2. Keep, switch, reciprocal, gone, negative square root 3. And the last page. State all values of theta. This is for your unit circle, as you know, where each function is undefined. Well, cosecant of theta is the same thing as 1 over the sine of theta, and that's the same thing as 1 over y, right? So where is y? 0, because you can't have a 0 in your denominator. So y can't be 0. Well, y is 0 at 0, 180, and 360. That's a full unit circle. Cotangent of theta is cosine of theta over sine theta. Same one. Cosine, same exact thing, is at 0, 180, and 360. All right, evaluate with your calculator. Woohoo! I thought y'all were just going to kill this one. There's still so many mistakes. You didn't check your radians or your degrees. So I'm in degrees currently. I'm going to take care of this one. It's cosecant, which is 1 over sine, 48 degrees. So 1 divided by sine 48, close, equals. And that's 1.3456. I asked you to round to 4 decimal places. There you go. It is not degrees. There's no unit with this. Okay. Then the cotangent is the same thing as what? Well, cotangent is cosine of 2 pi over 15 divided by the sine of 2 pi over 15. Is that how I did this? This is how I wanted to do it. Oh no, Lord, I could have used tangent. I'm so sorry. Ignore me. I'm making things harder than I need to. We have tangent on our calculator. Duh. So 1 over tangent of 2 pi over 15. The problem is make sure your calculator is in radians. All right, it's in radians. So I'm going to use 1 divided by tangent 2 pi over 15 close equals. And that is 2.2460. So 2.246. Do I need the 0? No, because it doesn't count. Even though it said to 4 decimal places, this is still rounded to 4 decimal places. Zeros past this point do not matter. All right. Use the reference angle for 11 pi over 3 to find the 6 trig function. Answer using the original angle. You must find the reference angle, and work must be shown using the reference angle. So we're going to take 11 pi over 3. I'm going to start by converting it to degrees. It just makes it easier for you. So 11 times 180 over 3, and there's nothing wrong with doing this. This is what you're going to do in pre-calc too, is 660 degrees. Keep that in mind. So we still need to find the reference angle. We need it at least to get it within the unit circle so I can see what I'm dealing with here. So I'm going to subtract 360 to get it inside the circle. So that's going to be 300. All right, what quadrant this is? This is in quadrant 4. So in quadrant 4, how do you find your reference angle? With degrees, it is 360 minus theta. 360 degree minus theta. And this is 360 degrees minus 300 degrees. So our reference angle is 60 degrees. Or if you're using radians, which is totally fine, it's pi over 3. All right, so I'm going to use my, let's see, I've got sine, cosine, tangent, cosecant, secant, and cotangent. Now, I don't care if you write 60 degrees or pi over 3. At this point, I just want you to show me using your reference angle. Muy importante. So pi over 3, you can't use theta because we actually have an angle here. If you use theta, I don't know what the heck you're talking about. You're just saying blue. I don't know what that means. All right, so let's find our reference angle functions. Looking at pi over 3, my cosine is 1/2. My sine is square root of 3 over 2. Everything should be positive. This is quadrant 1. Everything should be positive here because you're using your reference angle, quadrant 1. Tangent is sine over cosine. Sine is square root of 3 over 2. Divided by your cosine 1/2. Keep, switch, reciprocal. Cosecant is 1 over sine. Keep, switch, reciprocal. I'll rationalize later. Secant is 1 over cosine. Keep, switch, reciprocal. And cotangent is, I'm not going to use the tangent because what if I got it wrong? Cotangent is sine, I'm sorry, is cosine over sine. Cosine is 1/2 divided by square root of 3 over 2. Keep, switch, reciprocal. All right, this is what I wanted to see first. Now, we go back, we rewrite these with the angle you are given and put the signs correctly based on which quadrant this is in. Gnats are making me crazy. So sine of 11 pi over 3. Cosine. Tangent. Cosecant. Secant. Cotangent. All right. So sine is square root of 3 over 2. Just rewrite all this. We'll fix the signs here in a minute. Tangent is square root of 3. Cosecant is 2 over the square root of 3. Secant is 2. And cotangent is 1 over the square root of 3. Now, this is in quadrant 4. This 11 pi over 3. Remember, we found out the degrees were 660. But if we take a full rotation away, we find out that the angle is the coterminal angle is 300 degrees. That's in quadrant 4. In quadrant 4, who is positive? There's only 2 that are positive. It's cosine and secant. So those are your answers. Now, if you wanted your bonus points, as many of you wanted, you can only convert these two here by taking -2 over the square root of 3. You could have gotten that one, and then you got, nope. And that one. If you have any questions, please let me know. All right.